Okay, you guys, so the last type of equations that we have in section 1.5 are something that I playfully call hidden quadratics. I think the book uses something like reducible or whatever the case might be, but I like to playfully call them hidden quadratics, and here's why. Right, a quadratic, what we learned in the past, is something of the form ax squared plus bx plus c equals 0. It's essentially a degree 2 polynomial. So when you look at all the problems that I have on this handout, right, you'll notice that not a single one of them is technically a quadratic, right? This has a radical in it, so it's not even a polynomial. That has a radical, it's not a polynomial. This is a polynomial, but its highest degree is 4, and that's a polynomial and its highest degree is 6. So these technically are not quadratic by definition. Here we have a power of 2, but it's a negative 2. So this is very quadratic-like, but we need a positive 2, not a negative 2. And then here, right, we actually have a rational equation. Our polynomial's down in the denominator. So we got rational. And then over here, right, we have fractional exponents. But technically, these are radicals as well. So when we look at our definition of what it means to be a quadratic, none of these actually satisfy it. So they don't start off as quadratics, which means we have to either find it or reduce the problem to a quadratic, which I'll show you how to do in just a moment. The second thing I want to share with you before we go and find the hidden quadratic is for you to realize that there actually are other ways to do this problem. This is a radical equation, so we could isolate it and solve it, what we just learned in a previous video. Right? Same thing here. Isolate that radical and solve it with the previous video. So we don't necessarily have to put it in quadratic form. You can use something else. This one right here, as I mentioned, is a rational. So the idea to solve a rational was to find the LCD, multiply both sides by it, and clear the fractions. We could do the same thing here when we realize that this is 4 over x squared plus 4 over x minus 3 equals 0. So technically we have a rational expression here. Find the LCD, multiply both sides by it. So, and then some of you who are very good at factoring can probably think of a factorization right here that is very fast. And I apologize for that. I think a plane flew by. Let me go ahead and let them go and get that off the video here. Sorry about that. Okay, so so there are other ways to solve these without using the hidden quadratic trick. All right, so however, right, let's talk about how we find that hidden quadratic. Very important skill that we're going to use, and kind of your first idea of what we call using a substitution. Very famous math trick. And first of all, to realize if you have one or not, what you want to do is take a look, right? The first thing you notice is that any quadratic has at least 3 terms in it. So if you look at each one of these, right, they might not be polynomials, but there's 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So they all at least have, right, that quality of having 3 terms being added or subtracted together. The next thing you're going to look at is take a look at the variable part of the middle term. All right, so the variable part of this middle term is that. If we were to square it, right, do you get the variable part that out is in front? And the answer to this is yes. So this is basically a hidden quadratic. So we have that. Same thing here, right? What's the variable part? Well, it's the square root of x again. If I square it, I get x, which is the variable part out in front. So yes, this is a hidden quadratic. Same thing here, right? What's in the middle is x squared. If I was to square it, I end up with x to the 4th, which is out in front. So yes, this is a hidden quadratic. On and on. Now, obviously, these are all going to be hidden quadratics because of what I have. But again, here, right, we have x cubed. If I was to square it, I'd end up with x to the 6th, which is out front. So yes, this is a quadratic. Here, we basically have x to the negative 1. And if I was to square it, I get x to the negative 2, which is out front. So yes, this is a hidden quadratic. Here we got to be really careful, but if you look, right, what I have in the middle here, what involves the variable part is 1 over x plus 2. So if I square it, right, when we square a fraction, if we square the top and we square the bottom, we get that, which happens to be, right, 1 squared, right, that's 1 over x plus 2 squared. We get what out in front. So yes, right, that's a hidden quadratic. And then even these ones down on the bottom here, right, if I take x to the 1/4, remember it's just the variable part, and I square it, we get x to the 2/4, which is x to the 1/2, and that's what's out in front. So yes, that's a quadratic. And then last but not least, right, we have x to the 1/3. If I was to square it, multiply my exponents, we get 2/3, which is what's out in front. So that is how you recognize if we have a hidden quadratic. First of all, it has to have 3 terms in it, right, which all of these did. And then if you took a look at the variable part in the middle, you square it, you get the variable part out front. That's telling you that we have a hidden quadratic. All right, and so now that we have that, we have some inside information on what the substitution will be. But obviously, I need to cut to another video. We're 6 minutes into this. So let me go ahead, now that we've identified these as hidden quadratics, let me go show you the substitution trick and how we solve these hidden quadratics, knowing what we know. And I'll do that in a separate video. Talk to you guys then.